Alright, hey everybody. So, section 4 here, we are going to learn about how to convert between rationals or radicals, and exponents, and going back and forth. This is a really vital skill to have as an upper level math student, and this is something that you cannot do in the calculator, that you have to be able to do without the calculator. So, let's get started. So rational exponents. Rationals are fractions. Just another word for fraction. And if it's an exponent, it'll be raised from your base. So expressions with rational exponents can be rewritten as radicals using the following rules. So one example is if you have 1 in the numerator and then a number in the denominator of your exponent, then you will take the nth root of your number. So in other words, the n will become the root of your radical. And then your base will go here, and that's it. The 1 doesn't really serve a purpose, except it is really this value raised to the 1 power, but we don't have to write that since it's the same. Now, as you can see, I'll show you kind of more what I mean in this one. Let's say that the numerator is not 1, and we have a number instead. So it'll still be the nth root, so the denominator will go on the outside. Then you will have your root, and then you will have your base raised to your numerator. So it'll be a raised to the m. In other words, this one is a raised to the first power.
Can you ask custodians to go down to the cafeteria doors, please? Thank you.
Lots of announcements today. Alright, so these are the two rules. So the way I picture both of these in my mind is I always just take the top and I just tilt it in my head. I tilt it this way. So my fraction is like 1 and then n over here. So that gives me my positioning, and I just remember that. And so my n will go to the left, and my 1, or my number. So if it was the other way, I would say, alright, if I tilt my fraction, if I physically tilt it sideways, my denominator will be on the left and the numerator will be on the right. So that's how I remember what goes where. My denominator will go on the left and my numerator will go on the right. But the numerator has to go inside that radical. Okay? So this is how you convert your exponents into radicals. Let's go ahead and do some. So this one is an example. So I tilt it in my head. I tilt that 1 over, and then the 4 goes over that way. So that means my 4 will be on the outside. My x, my big number, goes under the radical. And since I have a 1, I don't have to put it. I can just leave it alone. And that's it. So it's just converting it from one form to another form. Okay? Exponent form to radical form. Which makes sense, right? Alright, let's try this one. So, this one. So we shift everything this way, or clockwise. You can also think of it as a clockwise direction. Everything shifts clockwise. So the 2 will go on the outside. Your 15n stays on the inside. And then from here, if possible, yes, you could see if you can simplify this, and we cannot. And you also don't have to put the 2, okay? So that's the same thing as 15n. Either way is correct. Okay, now let's do number 3, okay? Like I was saying, sometimes there is more work to do after you arrange it. So since we're putting it in radical form, move the 3 this way. So 3 will go outside, 1 will go inside. So the 3 radical 24. And from here, you just have to be careful that you cannot take any third roots of 24. And 24, let's go ahead and do this one by hand just so we get used to it. 8 times 3 is 24. The 3 is prime, but the 8 will become 2 times 2 times 2. So I'm done with the 8 now. And I'm circling groups of 3s. So this is how you do it by hand. Yes, you can do it in the calculator, but I just figured why not show you how to do it by hand. Again, just in case you need a refresher. So 3 indicates we circle groups of 3. So I take out a group of 2's, and then I have a third root of, who's left? 3 right here. So that would be my completely simplified answer. Okay. Alrighty. Let's do a few where we have a number or a variable and a number on top. Let's go ahead and skip and do 5. So shift it. So 2 will be on the outside. K will be on the inside with the 7. And then since this number is less than this number, we have to take out groups of 2, and we can. How many groups of 2 are in 7? 3. So taking out 6 altogether, leaving how many left? 1. Yes. So, and I'm just going to leave out the 2 because I know that square root's the same thing as nothing, no number. All right, and that's the answer for number 5. So, hopefully that doesn't seem too bad. Let's see if there's any others. Yeah, let's go ahead and look at this one, starting with number 7. So we notice that our base has multiplication. So let's see what happens when we do that. So start the same. 4 on the outside, A, B on the inside. But a good idea to do here is to put parentheses around, keep the parentheses. So again, we shift it this way and this way. 4 on the outside, 3 on the inside, and keep it as its own group. And then we just see if we can simplify anything from there. Okay, can we take out a group of 4 out of 3? No, we cannot. So the only thing you can do is go ahead and distribute this 3 in here, and we're allowed to do that because it's multiplication. If it was plus or minus, you wouldn't be able to do that. But since it's multiplication, it can be also written like this. All right. Let's see. Let's look at this one. All right, 3 would go on the outside. Again, just keep the parentheses. It's a good idea. 2. Okay. So we can square this value, and it is possible to square this value. We would square the 6 and the x, kind of like here. We squared this term or cubed this term and this term. So we can square the negative 6. What's negative 6 times negative 6? 36. Then we can square the x as well. Now, the only thing we have to make sure of is we don't have any groups of 3 and 36, which would be 3 and 12, which is 3 and 4, and 4 is 2 and 2. No, we only have pairs. So that's it. We can't do anything else. Alrighty. Alright, let's look at number 9. Now this one's even different. It's got this number out front. So when this occurs, that indicates that these are 2 separate terms. So this exponent of a half is not part of the 7. The 7 would have to have its own 1/2 if we were going to include that with the 7. But since it doesn't, it is just included with the item in parentheses that it's attached to. Okay. So what we would do is keep the 7 out front and then rewrite this. And since there's a 1, we don't have to put the 1, so just leave it like that. 12 will have some values, and that was what? 6 and 2, and then the 6 will become a 3 and a 2. So yeah, we have a pair of 2s. So that'll be 7 times. Take out your pairs. I'll just go ahead and drop this, and I'm left with 3. It's still on the inside, and W is still on the inside. And then simplifying the front. There you go. Alright, so that's something to keep in mind. Why don't you go ahead and try these other 2, 4 and 6, and see if you're good. Okay? Pause the video and then press play when you're ready. Hopefully that wasn't too hard for you. Number 4 resulted in 3rd root of 49. Number 6 resulted in 3 times the 4th root of 3. So this one happened to have a smaller number outside. So we had a group of 4 out of this 5. We took out a 3, which is a group of 4, and then leaving 1 left over. You also could have got this number, big number, 3 to the 5th, and then done that number divided by x to the 4th, and done the calculator trick to get 3 and 3. Alrighty, let's try now the other way, okay? So we're going to kind of switch this around. Instead, we're going to start with our radical version, and we have to change it into exponential. So let's go back to a different color. Alright, so now we got to think reverse, okay? What I had to start with was 1 over n, and then n was out here, and then x was raised to my 1 power. So now I'm going to shift it back the opposite way I came. I'm going to put this on the bottom and 1 on top. So 1 will move up, and then n will shift to the bottom. So in this case, my exponent, or sorry, my index will go to the denominator, and I know my base is 16. And then whatever my power is here, which in this case is a 1, will go in the numerator. So that's the same thing as 16 to the 1/3. Okay? See, again, not really something we can do in the calculator. This is a skill that you've got to be able to manage and do on your own. Okay? This is definitely important to higher level math. Okay? You will definitely use this in the future. I guarantee it. So here we have no number, but what we got to remember is that it's really a 2. Okay? So my denominator is a 2. My numerator, there's no power there, so it's a 1, and I have x, y. Now remember, before when we had 2 terms multiplied, we had to put parentheses around them. So we got to do the same thing in this case, or it started with parentheses, and that way it says that both terms are raised to the 1/2. Otherwise, if you don't have those parentheses, who is raised to the 1/2? Only the y, okay? Because remember, x can have his own exponent as well. So that's why the parentheses are important, okay? The parentheses separate and indicate that both of them are raised to the 1/2, or that the whole term itself. So it's best when you do this to just go ahead and put whatever was under your radical, just put it in parentheses. And then you can worry about it after that. Alright. Delete my other stuff here. Okay. Alright, so I think we'll be good on 12. Let's do one that doesn't have, that has a number, or that has a number underneath as well, just to get used to it. Let's look at 14. So 4, so we'll move to your denominator. And then 5 moves to the numerator, and your base is k. And if you're ever unsure, just go back and try to flip it back to this method, see if it works. Okay, 4 goes out, 5 goes in. Yeah, I did it right. So we're good. That's it. So these are, can be pretty quick. Alright, let's see. What else can we do? This one has a negative. I have a feeling some people are going to be thrown off by this one. So this is kind of interesting. We have the 5, but we still have a radical, which is kind of strange. But it's on the outside. So it looks a little different as opposed to these. See how my number in some of these other ones is underneath the radical, but this time it's not? Well, let's just work with the inside and see what happens. So my base is negative 2a. And then 4 is my denominator of my exponent. And since there's no exponent on the inside, let's go ahead and put a 1. Then, outside of all of that, I have my 5. Okay? But there is a rule that when a power is of a power, we can just multiply them. So really, we just end up doing 1/4 times 5, which is 5/4. And then we've gone to one single exponent. And that's all we have to do. So it's kind of weird in this case that when the number your numerator number is out here, but it's not under the radical, it's still outside parentheses, it just still ends up being the same, okay? So you don't have to freak out too much on that. It's still the same method. Your denominator's to the left and your numerator is to the right, okay? So that's kind of neat. It works out that way. Alrighty. Let's see if we got, I think we're good enough to let you try those. Yeah, why don't you go ahead and pause the video and try the rest of these, and then press play when you're ready. Okay, check out your answers. Oops, I guess we were just doing 12. 12, 13, 15, 17, and 18. Now with these, you technically could do more with these if you wanted to, and kind of depending if what the choices are, like if it's multiple choice, you can continue and distribute this 1/2 to everything and do like 10, it would become 5/2, and then this one would become a to the 3/2, b would be raised to the 1/2. So that, yeah, potentially you could have to do that, but I'll just let you know in cases if I want you to do that, but this is fine as well. So, same thing here, you could do the 1/3 of 9 raised to the 1/3, this raised to the 1/3, multiply 7 times 1/3, and 4 times 1/3, and break that down even more, but for now we're just trying to convert back and forth from radical to exponent, so that'll be alright. Okay. So let's see what we got going on in the next one. So this is when we have multiple versions multiplied together, and how we can simplify these. Rewrite all radicals in exponential form, and this is a if needed step. Use your exponent rules to simplify, and then write the answer as a radical in simplest form. Okay, so let's start with this one. So in this case, we do not have to write this in exponential form because it's already written in exponential form. And we are trying to get this into radical form. Yeah, so pretty much for all of these, we're trying to get in radical form is the best. Now, nice thing with this is you can, when you multiply items, you add their exponents, okay? So since they have the same base, I can add them, kind of like x squared times x to the 3rd. That results in x to the 5th, kind of like that. So keep the same base, add the exponents. The 1/3 plus 4/3 is 5/3. And then we do our switcheroo, so the 3 will go on the outside. And then 5 will go on the inside. And then we ask ourselves, do we, can we take out groups of 3 out of 5? Yes, you can take out one group of 3. But you are left with how many? 5 minus 3 is 2. So we are left with x squared. So that would be simplified all the way out. Okay? Alright, I'll leave you that one to do for later. That should be pretty easy. Okay, now what about when we divide? So we've kind of just done this before, a little bit earlier. If you have x3 and x squared, what do we do to these exponents? Subtract them. The top minus the bottom. That would result in just plain old x. Remember, that's the same thing as x times x times x divided by x times x. You cancel out, and then you're just left with a single x. It's the same idea. So, since we can subtract the top minus the bottom, we can do the same thing. So we can take m and then do 5/2 minus 7/4. Now, the one issue here is you have different denominators, so you can't do that quite quickly. So let's just jump to the calculator. We can do 5/2 minus 7/4. We get 0.75, and I know that's the same thing as 3/4. Alright, now I'm going to go ahead and change it to radical, since that's what we're trying to do. So shift your fraction, the 4 will go to the left, the top will go to the right, so 4 root of m to the third. And this is bigger, so we can't take out any groups of 4 out of here. So that is all we can do on that. Alright. Like this one, when you have a power to a power, I said this a minute ago, you can just multiply these and get one exponent. So multiply your numerators. Remember, in multiplication, it doesn't matter that the numbers are different, that the denominator is different. But when you subtract, you want your denominators, or add, you want your denominators to be the same. Okay, so that's why I went ahead and just did the calculator. And I can convert this one to a denominator of a 4 if you want to do that. So this would be 1 times 5 is 5 over 2 times 3 is 6. And then you just convert again. And boom. That was nice and quick, wasn't it? Alright. You can do 23. Alright, 24. Yeah, let's go ahead and do this one. So there's a couple ways you could dive into this, okay? We can go ahead and, since we've got this raised to an exponent, go ahead and flip my 2/3. So the 3 would go out. And then 8x squared. And then my 2 would go in. So you can start off that way. Okay? Another way you can do it is go ahead and distribute the 2/3 to both items. Or, well, let me just do a different color. Or, you can say, alright, 8 is raised to the 2/3. And then this is raised to the 2/3. So I just do 2 times 2 and get 4. So that would become 4/3. X to the 4/3, 8 to the 2/3. So we'll go ahead and finish both of these and kind of see what it looks like, how much work it took. So 3 on the outside of 8 squared times, again, 3 on the outside of x to the 4th. So the nice thing about this way is you already are doing it separately as your number and your variable. So that could be kind of nice. Alright, so that's 3rd root of 64. And then I can take out a group of 3. So I have x, 3rd root of x with 1 left over. And then the 3rd root of 64. Come back to me. Is that 4? Yes, it is. 3rd root of 64 is 4. So this will change to a 4. So it's just 4x, 3rd root of x. Okay? And then let's go ahead and finish it the other way. This way. Okay? So now I can distribute my 2 into each of these. Or you could do them at once and do 8 squared is 64. It really doesn't matter. See, there's a lot of ways you could do these. 64 and then x to the 4th. 3rd root of 64 would come out and give you the 4. And then take out a group of 3 out of 4 and give you your x and then the 3rd root of a single x left over. So, I mean, both really work out in this case. So, you know, it's really up to you, but it doesn't matter. You should arrive at the same correct answer, depending on what you decide to go with first, okay? So, go with whatever makes sense to you, and just be careful along the way, you know, with your multiplications and just little stuff. All right. Let's see what we got now with, all right, I'll leave that one. So we have negative exponents thrown in here. Very interesting. So let's do a couple of those. So let's do 25 and 26 to kind of get our bearings with negative exponents. So What's going to occur when you have a negative exponent is that that needs to go to the denominator. For example, if you ever have x to the negative 1, that'll result in 1 over x. Okay, so that's just a rule that I guess I probably needed to remind you of. So 1 over, and then I'm just going to go ahead and get rid of this negative immediately and put 100 to the 1/2 in the denominator. Then I can do this and flip it and make it a radical. So my 2 will go for my radicals. It's regular square root, and then 100 to the 1 power. Square root of 100 is nice, so we know we can't have a radical in the denominator, but it is a perfect square, so we got lucky on that one. So it's 1 over 10. Okay. Now, there is no way to do the negative like first. It doesn't mean that, oh, we take the negative and put it out front, and then we square root 100 like that, like move the negative out and then just convert that, because that would give us negative 10, and negative 10 is not the correct answer. So that is something you definitely do not want to do. Don't be tempted that a negative exponent is going to make your answer negative. That is not the case. Okay. Now, if you have a case like this where we have the same base with exponents, we can combine those add the exponents like we did with the x squareds up here. If we have x squared times x to the third, we add them and get x to the fifth. So that's what we're going to do right here. We can add these since they both have a base of 16. We would just say, all right, it's 16, and then I add these two, so 2/3. But in this case, I'm really going to minus because this is a negative. So 2/3 minus 1/3 is 1/3. And then now I'm going to convert this into a radical. So third root of 16. And then are we done? We got to make sure we don't have triplets of 16. Let's check. So 16 would be 4 and 4, which is 2 and 2 and 2 and 2. And yes, I do have a triplet. So I actually have to simplify even more. So then my triplet would go on the outside. And then what's left is a single 2. So that would be completely simplified. So again, this looks like it's done, but it's not. We got to be really careful that our numbers under the radicals cannot reduce even more or simplify even more. Okay. Why don't you go ahead and try some of these? I think you're in a good spot to be able to do these on your own. Just see how you do. Really, really important to practice these on your own because that's what's going to prepare you the best for your upcoming test. Okay? So go ahead and pause the video and try these out. See what you get, and then press play when you are ready. Alright, let's get going on reviewing these. So, number 20, p times the fourth root of p to the third. Number 23, 2 times the fourth root of 2. 27, negative 1/6. 28 is 1/2. 29 is 6, the root of v to the fifth. One thing to just be careful of is when you're doing this, again, your exponents of 1/3 times the same base with a 1/2. You add these exponents, but 1/3 plus 1/2, you have to get a common denominator, and that is 6. So that's really 2 out of 6 and 3 out of 6, which becomes 5 out of 6, and then becomes this. Okay, so that can be kind of tricky. Here's 30, which is r times fourth root of r. Number 31, 2 times the third root of 2. (32). Change these to exponents, subtract their exponents, Get 7. Now 33, there's some tricky stuff here in this one and 34, so I'm going to talk a little bit about these. So there's two ways you could go about this. You could say, alright, I have this number is smaller than this number, so I can go ahead and take out groups of 4. So I can take out 2 groups of 4, so give me x squared, and then 4th root of, I have 2 left over. Now, the only thing that I want to add here that will help you, how do I simplify this to this, is that this is really a fraction of 2 over 4. So 2 over 4 will reduce to 1 over 2. So 1 and then squared. So that's how this answer and this answer are the same. You could also do it this way and convert it into an exponent and then simplify the exponent. So that's all I was essentially doing here, was say my exponent is 2/4 and I reduce it to 1/2. Give me a 1 and a 2, which both happen to disappear. But in the 10/4 method, or in the exponent method, you can see it a little bit better. A 10/4 simplifies to 5/2, and then you convert it back into radical, because that's ultimately what we were trying to do, is get it into radical. And so that I see where that could have confused you if you were like, oh, it's already in radical form. But we can simplify it even more, like reduce these numbers. So that would give us x to the 5th, but we can take out groups of 2 from x to the 5th. We can take out 2 groups of 2, and then have 1 x left over. Alright, now this one can be kind of messy as well. It's like, okay, this is a radical, and I can see if I have groups of 4 out of 25, which I don't, it's only 5 times 5, and then see if I have a group of 4 out of this, which I don't. So it's like, what do we do? Well, there's a couple things we can do. We can go a long way, which will convert the 4 into your exponent. But just telling you, this is not the quickest way. You can keep going and say distribute the 1/4, and so I'd have 25 to the 1/4, and then m to the 1/2, but then you have different x denominators, which gets it kind of messy. So I want to show you this, kind of a trick here. If you can get this, so m is squared, but 25 is not squared. So I can't just say, alright, it's 25 m to the 1/2. I can't do that because of the 25, okay? But I can do this. I can convert the 25 to where it has an exponent of a 2. In this case, I know that 25 is the same thing as what? That has an exponent of 2. What number squared gives me 25? 5. So I would have 4th root of 5 squared times m squared. So now both of these can now be combined. 4th root of 5m with parentheses squared. Now I can convert it, since both have the same exponent, convert it to my rational exponent, which is 2/4, which simplifies to 1/2. So I have 5m to the 1/2, which is basically the square root of 5m. Okay? And giving you the answer. So that is more simplified than that. Okay? So those are pretty tricky. Okay? We'll probably have to do more practice with those. So that's it for this video. So thanks for watching. See you next time.